Hello, thank you for joining us today. Welcome to the User-Ready webinar series. This is Paul Petto, Director of Operations at User-Ready. Today's program is Optimizing Tableau Workbooks and will address desktop and server-related performance topics. Who is User-Ready? We are a leading provider of self-reliant data solutions specializing in end-to-end delivery of Tableau and related technologies with proficiency in Agile, visual analytics, data preparation, governance, and security. We're a global company with offices in New York and New Jersey and a growing offshore presence in Bangalore, India, and Beijing, China. User-Ready is proud to have these recognitions in the marketplace in 2015. We are the Tableau Services Partner of the Year. Red Herring Magazine ranked us in the top 100 technology companies in North America, and User-Ready was number 113 among America's fastest growing private companies in the Inc. 5000 list. Today's webinar will be approximately 1 hour, including Q&A. This is part of a series of webinars that will be presented throughout the year. Allow me to introduce your presenter. Vizul is the Chief Technology Officer at User-Ready and is responsible for developing our technology vision. He likes the simple summary of techie guy. Anand has authored numerous papers in the field of computer science, data analytics, and BI governance, and previously conducted many webinars of this type.
Thanks, Paul. Good afternoon, folks. What we're trying to do today is look at the long pole in the tent, our philosophy of how to make a Tableau workbook as fast as possible. The webinar itself is broken into two halves. The first half is all about Tableau Desktop optimization. So we will take the workbook that you're seeing and actually optimize it as fast as possible. There'll be time for questions, so feel free to ask questions at any point of time using the chat function. During the middle of the seminar, we're going to take a quick view of what questions we have on the desktop before switching over to the second half, where we look at server optimization. On the server side, we are looking at a tool called TabJoker, which actually puts load on Tableau Server. The first half is all about a single user and making the workbook as fast as possible. The second half is taking that single user optimized workbook and scaling it out to as many users as you see fit on the Tableau Server. So let's get started. Before we actually dive into what makes a workbook as fast as possible on the desktop, let me show you the workbook that we are looking at. So here is a typical workbook. Let's say you as an analyst or one of your analysts has produced a workbook, which is a decent looking workbook, and it's got things laid out for, in this case, a supply chain summary. You as an interactor might look at this workbook and start going in, either just looking at the view as is or interacting with this workbook. What we are going to do is look at both of these scenarios while we are doing performance analysis. You could play with it, which is what I'm trying to do, or come back and select a couple of things. Maybe you don't want to look at coloring, not interested, or you're only interested in a couple of states, or in this case, all the states in the US. So essentially, the workbook will interact based on what you give it as a question, or you're probably interested in just looking at the current sales, and you're seeing, oh, this current sales was down when compared to last month. Let's see what is happening there. You can look at the sales versus inventory, look at a specific sale, let's say quilting, and look at how this sales ratio actually worked, whether there are things in stock, out of stock, and things like this. So essentially, what we are trying to do is look at a workbook and go through this workbook. Assume this is your workbook. You've been given this, and you're ready to give it out to the masses. How do you make this as fast as possible? What we use is a built-in Tableau tool called performance recording. So before I jump in and actually show you performance recording, I want to ask you guys a quick question. Here's our first poll. Please take a moment to answer this. Have you used performance recording? And let's see how many people have. Numbers are coming in. Let's give it a couple of seconds. About 54% say, well, you've never heard of it before. The others is, no, but I've heard of it. But my good friend who actually does dashboarding for every day, day in and day out, should know. Give it one more second. Let's close this poll, and I'm going to show you what the results are. Okay, let's close the poll. Looks like it's stable. And I'm going to share the results. See, about 50% of you said you've never heard of this before. So this is a good webinar if you haven't heard of this. And for the others, you're going to understand how to actually go into the guts of a workbook and make it fast on the desktop. So how does performance recording work? So let me just close the poll, and we'll come back and look at what this performance recording is about. We come back to our screen. I'm just going to go out of full screen mode, and let me go in and actually show you what this performance recording is. Performance recording on any workbook is under Help, Settings and Performance, Start Performance Recording. Typically what you do before you start performing performance recording is you close the workbook and start with a fresh workbook, so it's not cached anything. So let me close this workbook out. Let's say, yes, I don't want to change, I don't want to save any changes. I'm going to open this workbook again and let this come back up, right? So now let's look at the first thing that you need to do is make sure that you're on a page that you don't want performance recorded. So I move to a page that's not there. We're going to start the performance recording. Now we're going to navigate to the page that you want the performance recording on, this view. And we're going to interact with this view just like we did the last time. Clicking on a couple of things, viewing it as is. But while we are doing this, Tableau Desktop at the back is keeping a track of your actions and how long each action took on your desktop. So it is going and making sure that it can categorize all the things that we are doing and where does the time take and how long does each of these take. It's keeping track of all of this. So I'm going to take a little bit more time. Let's do a normal performance recording that we just did the last time. I'm going to go through sales. We're going to look at the details just like we did the last time. And we're going to go back to the main page. At this point of time, I'm going to stop performance recording. I'm saying this is my optimal path that I see most users taking. So on your workbook, it might be different. You might be looking at a set of actions. So make sure you get that, track it, and say, if 80% of the users are actually going down this path according to you, go and actually do the same thing while you're doing performance recording. Once I stopped it, you see Tableau's open up another window, and it's actually showing what performance was actually running. So it is compiling that actually took the longest time. This is the longest pole in the tent. All the others are smaller than this. So it's showing me 2.10 seconds. It'll be a different number, and we've seen numbers as big as, let's say, 15 seconds to 20 seconds right on the desktop. But compiling of a query is something that Tableau will cache most of the time. So I can hide this. So I'm going to exclude that, and then I'm going to look at what's the next longest pole in the tent. Cut that down to size. That was compiled again. Don't worry. Tableau will take care of it once you cache it. So the second user who comes in will not see it. What's the third longest pole? A query, which says worksheet help actually took the longest time. How do you know what query this actually took? the query is shown at the bottom. So let's take a look at this query. Now this is important. So when you look at the query, when you copy it as data, a small gotcha there. Once you copy it as data, whatever you see here is going to be shown. I'm going to open up Notepad and let's say I paste this query. We're looking at what the query is and see what the aggregate is and see what the thing is, right? So this query itself took a long time, and most of the time it was C category. How do I know what C category is? Let's take a quick look at C category and what that is. How do you know what the C category name is? We can go in and take a look at this. So I'll take the workbook that we're actually looking at, not the performance one. Here you go. And let's look at what that help actually had, right? So we'll go back and we look at what that specific help page was and what is taking that long. This is the help page. Let me go to that sheet. When you look at this sheet, what strikes you is it's a very simple sheet, but it's got a query called underscore state and an underscore subcategory. These are custom calculations that you can see up on the top. Typically, that is what takes the most time, right? So let me go in and look at what this custom calculation is. This custom calculation has a big string calculation where you have a 2-letter followed by a whole set of spaces being translated to Alaska. This is a very heavy kind of calculation because it's just doing string manipulation. Our advice typically when we see things like this is take this and do it either on the database before it comes in here, or create a parameter where you have all of that list mapped out so you don't have to do this every time somebody clicks it. It's going to be passed once and kept inside the workbook. So let's look at another calculation as a quick example. Let's say you went in, you said this is where the performance was, right? So let's look at the workbook that we just had. What is the next performance? Again, help. What's the next one? Again, current term. So let's look at this query. Look at the data. I'm going to take this. Look at what this is. This is interesting. This is a big long query and looks like this calculation 14188 seems to be in a couple of places. So it's like 5, 6, 10 places. So if I can take this calculation and see what this calculation is, I'll get to the bottom of how to speed this up. So how do you look at that calculation number and know what field it exactly references? When you look at a workbook, it's typically packaged as a TWBX. So here is a typical workbook, our workbook that we had. What you can do is either unpackage this workbook or take a copy of this and just rename it as a .zip file. It's nothing but a zip file. Once you rename it as a zip file, you can unzip it, just like using any of your zip tools, or like what I'm doing, I have another tool that I'm just going to take a quick look. Let's open this and take a look at what that query is. What was the query number? We have it here, and it was 41488, ending in 41488. So let me go in and actually look at what query 41488 is. The name that Tableau Desktop and Server know it within itself is called calculation something, but what we as analysts see is the underscore state. So you saw that whole string calculation, that was taking a long time there. So you will typically see this, and this is a trick that you can use to see what calculations are taking the longest time. So we could go in and then eliminate the actual calculation or change the workbook so that calculation is not used. What I've done is the latter. So I've taken our workbook and I've actually taken the same exact view and taken out all those pages. So let me show you what the other view looks like. I called it imagine no state. You see, I removed the state up at the top, removed that piece and made it clean. Very similar to John Lennon's song, Imagine No Country. We called it Imagine No State. Okay, so this is a way of actually eliminating that specific calculation. Now, you could do other ways of optimizing it once you understand what that calculation is. What we're going to do now is benchmark this view. So let me go in and let's close this out. I'm going to benchmark that specific view and let's see how it goes. So this cleans up all the cache. I don't have to worry about what has been there and what's not there. Let's open this up again. We started off on a page that doesn't need performance recording. I'm going to start performance recording. Now we are going to imagine no state. First time we are seeing this as far as Tableau Desktop is concerned. It's going to run through this view, and we interact with this view just like we would the last time and the time before. I'm going to go back to art supplies, take the time frame, pick a category, or remove a category that I don't want in this case. Go into a subcategory, let's say, and remove one. Go into current sales like we did the last time. Pick something. This time it was sewing. And go in and look at the details. We go back to the main page, and then I'm going to stop performance recording. Help, settings and performance, stop performance recording. This is going to open it up, and then we'll see what the next longest poll in this tent is going to be. If it is compile, we're going to ignore it. So it was again compile query. This time it didn't even have a worksheet, so you can safely ignore this. This is not going to happen, right? After the first user would use this. Rest is current turn. So that's the next longest poll. But now you see it's already come down from 1.5 seconds the last time to 0.79. So this is the process we follow. Find the longest poll, see if it affects us. If it does, go into the details. If it is a query, find out the field that is actually doing the query. Then run it. Make sure it is optimized. Come back and benchmark again. Right? So let me pause here for a second. What we wanted to do was actually look at the desktop side of things. So we've taken that, looked at state, actually eliminated that in a calculation, and we are going to come back and look at server in a short while. So I'm going to turn it over probably around mid-time of around half of our webinar time. I'm going to turn it over to Paul to see if we've got any questions and how we're doing.
Right on, thank you. Do you want to poll them for the pace?
Yes, definitely.
I do. And I'll check for, we have a few questions. Let me see if there's any new ones. Okay, so please respond to the poll, and if you have any questions, put them into the chat. Do have a couple in reserve here.
Okay. So here are the results of the poll. About 76% a view, say, the pace is perfect, don't change it. So we're going to keep going as we just did, right? Paul, over to you.
Great. Thanks, Anand. So while we're in this little break, let me put in a shameless plug for UserReady. We are providing for dashboard assessment. You give us a dashboard with issues in 30 minutes of your time. We'll test it on Tableau Desktop and Server, identify the bottlenecks, go through the process that you're learning today, and show you how to fix it. And the details on that will be in a follow-up mail following this webinar. Thank you. So Anna, we have some questions. I think these two they kind of overlap. What elements influence performance, and what if it is not a query that is taking time on the desktop?
Oh, that's a great question. There are a lot of things that influence performance. Query is one of them. It's not only that. It just depends on the amount of data coming back. And if the view is actually showing 10 million rows, it is going to go slow. Or if the view is so complicated that you have a lot of things going on in the view, that would slow down too. But think of it from a normal human being's perspective. If you overload them with a lot of data, comprehension is going to reduce. So we have an upcoming webinar that actually talks about our methodology of reducing complexity on the view and on the data in one shot. Be sure to take a look at that also.
Another question. My dashboard is slow because it has a lot of data. How do I speed it up?
So same answer again. It's the webinar. Take a look at that. You'll be able to see how to reduce this. And we have a very specific methodology called MAD, Monitor, Analyze, and Detail. You'll be able to look at how to apply that methodology on your dashboards and how the data can be aligned, shaped, reduced, summarized, so that dashboards can become faster.
Well, I think this question anticipates looking at the second part of the webinar. So what if my dashboard runs fast on the desktop, but runs slow on the server?
Right. So this is perfect segue to the next half. So if there are any other questions, let's hold it, and we'll come back to these questions towards the end. So let's go into what we've done so far. We've looked at the first half, which is dashboard optimization. Taken a dashboard, we know how to go to the bottom of what is causing a performance bottleneck. How do you eliminate that? We saw a couple of examples there. Now we're going to switch it over to your server. Let's say you got your dashboard optimized as much as possible on the desktop. Now you're ready to release it to the server. So what do we do on the server? We push the dashboard up and then try what we call as server optimization. Before I get started down server optimization, I want to open up another poll, just one question. Have you used TabJoker before? If you have, let us know. If you haven't heard of it, we'll show you what TabJoker does. So 85% at this point of time say, well, I don't know what TabJoker does. So yeah, we are going to go into the details of TabJoker. I'll show you how this works. And then we'll come back and see how we take advantage of TabJoker. Good. Couple more seconds. Looks like it is stabilized. I'm going to close the poll. Let me share the results. As you can see, about 75%. So we will go in and look at TabJoker. Here's a quick view of what TabJoker is. At a high level, TabJoker is a command line utility released by Tableau into public domain that helps users actually load test their views on Tableau Server. It runs on a desktop or laptop or another machine, needs Postgre on it, which is a database, runs as a command line like you see there. You can configure it to actually show the views that you want It'll send a request to Tableau, and it'll get a response back. So while this runs, I'm just going to quickly show you how this runs. Let me start this. So here is my view. I've set it up on my machine. I've got Postgre running. So let me just run TabJoker for you. So it's got a bat file called Go, and I'm running a view and interact load test. So this load test is looking at a combination of viewers and interactors on a box. It's running for 2 minutes, and it's simulating about 60 users. So let me kick it off. What it does is it goes in, looks at your configuration files, and starts a load test. So here is how it looks like on the back end. I've got it configured and sitting up. While this is running, I'm going to show you what the pieces are. You can download TabJoker from GitHub, the world's open source platform for saving source code. Once you install it, it comes up with a folder like this. It gives you a configuration window, and there are a lot of blogs out there that talk about TabJoker. Chris Russell has a fantastic set of blogs on showing you how TabJoker is. Google him and you'll be able to find that out. So what it takes is a set of config files. I'm going to quickly show you what this is. I've got a URL called summary imagine no state, the one that we just looked at a couple of minutes ago. That's the one that I'm going to hit time and again. I've set it up in such a way that 60% are interactors, so they click, drag, drop, and actually interact with the view, and the other 40% are just viewers. I've set it up for 60 concurrent viewers to hit it. In a real life, that's about 600 users. Set it up in a box which is bigger than what it needs to hold 600 users. So one of the assumptions is you know how to size the box. Average rule of thumb is about 10 concurrent users per CPU on the server. But we can always help you with that kind of thing. Tableau can help you too. So there are other config files that you can take a look at this. I'm just going to quickly go through that. What URL are you going to hit? And what user are you going to use it with? That's one piece. There are other config files saying which database are you going to hit. This is my local database, and that is what I'm going to use. Are there any other things that you need to config? Pretty much it. Right? That's all we have, and once you set it up, it's going to keep running. It goes, ramps up, then comes back down, and at the end of the run it says, oh, I'm done. Take a look at it, and here's an ID. It gives you an ID saying ID 4 to view a result in Tableau. What Tableau's done is actually given us a workbook that can take these results and interpret them. Let me quickly switch over to that workbook. So here's the workbook that Tableau's given. Standard workbook. Let me go in and refresh this data. Once you refresh this, what you will see is the next ID has come through. So ID number 4 was ours, and it takes an average response time of 22 seconds. If you look at 90% success response, it's about 54 seconds. The same thing was about a second and a half, 1.5 seconds, 1.7 seconds for a single user. But now when you run it under load, it's actually taking 54 seconds. So there's something that's going on the server under load that's making this workbook slow down. So how do you know what exact place the slowdown has occurred? You'll have to do a performance test on the server. So how do we do that? While running TabJoker, we are going to do a performance recording on the server, and I'll show you how to do it. So let me start TabJoker and then show you the performance recording. Performance recording can be turned on a Tableau server by appending something to the URL that you're going to hit. the thing that you're going to append is this record underscore performance equal to yes. You have to turn on performance recording for at the site level. So if ask your admin, and if you are the admin, you go in and take a look at that. Again, the Tableau admin guide is a fantastic resource for how to turn on record performance. So while this is running, let's go in, open up a browser, and see how fast this is. Do we actually see it as a regular user? As you can see, I opened it up. Performance recordings already started on the server. And what I'm trying to do is see how this view behaves when going through a regular user. So I'm the 601st user on this, or the 61st concurrent user. You see how the speed is, approximately 10, 15 seconds maybe. But this workbook is shown as a viewer. So let me just quickly interact with it while Tableau is running, while TabJoker is running. So you could see it is still running, going through strong, and you'll see how the user is actually behaving, how it behaves for a regular user. I'm just going to go one more piece, regular user interaction. While this is coming through. Still running. Doesn't give me any errors so far, so I don't see any error here too. Let me go into art supplies. Let's see how the thing is running. Still running strong. It's not ramped down, so it's still 600 users or 60 threads that are running. Right. Now I can stop this performance recording. Assume I've got enough what I need on this imagine now state. I can click on show performance recording link right there, and that will show you a workbook on the web very similar to what you saw on the desktop. So what is taking the longest time? You see 14.55 seconds is the longest. What was the query? The query is about 1 second. So something else is taking a really long time. Let's see what that is. It was building the view that actually took the longest time. And we see this time and again when we are actually benchmarking this. What actually happens in a desktop when you're creating a view is when you look at the desktop, I'm going to show you the desktop for the workbook that we just did. Right? We go back and forth, make changes to the desktop on the view till we are happy with the view that we want. So let me just go back here. Right? So the view that we were looking at was imagine now state. I'm going to come out and show you this view. Looks deceptively simple and straightforward, colorful. But when you look at the dashboard, what is happening on the inside is it leaves a lot of containers. So under this dashboard, there is a horizontal container, and I click on it, it actually shows you where that horizontal container is outside. Inside this horizontal container, there's another horizontal container. And inside that, there's another horizontal container. So this typically happens until you get to a point where you actually see the view. I could keep going on like this, but this was a dashboard that we had used a lot of going back and forth, adding things, removing things, adding things, etc. So what we've noticed is each one of these horizontal containers that you see in web speak becomes a layer inside the browser. Every layer takes a little bit of time, and this is typically what happens when the view is built. So what we've done is typically the rule of thumb is if you have two containers just like this, horizontal and horizontal, you can safely remove it without making any changes to the view. I'm going to show you one, right? So you could remove this. Nothing changed in the view. I'll take another, remove it. Nothing changed in the view as well. So you see what I'm trying to do. Take all the containers and reduce them so that it doesn't have to do unnecessary empty containers or divs or containers in the web when it translates. This we've seen gives us a lot of speed up. What I've what I've done is I've taken all of that, removed it, and called it Summary, Imagine No Borders. Going back to John Lennon's song. Imagine there are no borders here. How do we see it? Straightforward. As soon as you see horizontal, you'll see tiled. Under that, you'll see two vertical things, and under that, I will see the actual thing that is the view that you see. So I've got all the different pieces directly there. I've removed all the unnecessary containers. So this is called Summary, Imagine No Borders, and this is something that you will have to do on the server once you get this workbook optimized on the desktop. That gives us the speed. So what you typically do at this point is take this workbook that you've optimized, push it up on the Tableau server, run another load test. I've already set all this up for you. So what I'm going to do is run another load test and actually show you the results. So here is Summary, Imagine No State, and here is Summary, Imagine No Borders. Imagine No Borders. I'm going to take that, make a copy of that. And it needs to be called vizpool.csv. I'm just going to delete that and rename this Imagine No Borders copy as vizpool.csv. Then we are ready to run another load test. I have to change the 3 underscore again. Let me just take that out. So we are ready. Okay, now we are ready. I can now kickstart another run, but this time I'm going to hit it on Imagine No Borders. You will get a speed improvement there. Here we go again. It's the same viewers and interactor mix. 60%, 30%. Okay. So while this is running, we're going to go back and actually test how well we are running as a regular user. So let me just go in and take this Imagine No Borders, and we're going to come up with that. Let me just open that up. So now we're going to do performance recording on Imagine No Borders. This is one step at a time. This is the first piece. So what we do is we go in, we benchmark, and we see how fast this is, what is taking the longest time, and whether that has performed what we need it to be. So you take it one step at a time. So now you see what the longest pole is, try to cut up that longest pole. Then you see what the next longest pole is. Try to cut that up so that you could get a speed up in response. The view is still loading, and while it's loading, let's see if the load is also running. Okay, there you go. Load is running, view came up. Let's do a couple of things on the view. Still running. About 60. Let me just take art supplies. Switch that over. Let's go and select another category. Let's see if the load test is still running. Okay, it's still running strong. Still no errors on the view. You came back. We'll do one more click before we actually stop this. Oh, so I got a data exception. That might be logged in as the first error. So let's go in and look at performance recording for this. Okay. So while this is coming down, let's see if this is done. Okay, so it went down to ID 6. And this time, you see that it came down from about 14.5 seconds to 9 seconds. And what's the thing that's taking the longest time? Could be the view again. Oh no, it was not the view. It was uncompressing the workbook that actually took 6.48 seconds. How much did it take to build the view? Let's see. So I'm going to see only build view, but what you see is build view itself was split up approximately into 8, 8, and 9.8. So it went into 3 separate views. So instead of one big monolithic view, it actually built it into 3 small pieces, did it in parallel, and reduced it to about 9.8 seconds. The uncompressed workbook, you can ignore because that will be a product of cache that will actually go back in. So we took something that was like running at 40 seconds, and let's see how good we did it, how better the actual result was. So it's ID number 6. So let's go back to this workbook that we had. We can refresh this. And let's see how good this was. Should be predictably a little bit slower. So it was 54 seconds, number 4. We reduced it to 37 seconds on a 90% success rate. So it's percentile-wise, you approximately got a 25 to 30% speed up. Along with this kind of view, it actually shows you, this workbook is pretty interesting. It actually shows you all the different runs and how long each one of them took, whether there were any failures in any of these tests. Failure was 0%, which was good, but we had one failure that didn't happen on the interactive, but we had it on the view. And the test response time, we just saw. What was the response time percentile? We just looked at it, and we look at what was the best view so far. So you could see 6 smack dab in the middle, and it was a pretty slow growth, and then it went up a little bit towards the end. It also tells you other things on the server if you have set it up that way. It can tell you CPU and memory on the server, how good Tableau Server processes actually took. In this case, since I was running on a remote machine, I don't have all the stats, but you could configure it in such a way that the stats are there. So in essence, this is going to be your tool to actually see how good the performance was on the server. If you need to make any changes, pull the dashboard back down, make the changes, put it back up. So this is typically what you will see when we are doing performance monitoring. Let me switch over back to our standard view, and we see what we have covered so far. In summary, what we've done is essentially called the long pole in the tent. It's a framework to optimize Tableau workbooks on desktop and server, right? To optimize on the desktop, you've seen how to do that. Do performance recording, optimize on the desktop before pushing to Tableau Server. Use the performance analyzer. Then on the server, use TabJoker. We saw how to configure TabJoker, what do you need to set. In combination with performance analyzer, while running under load, you will be able to see what actually took that load and see if you could remediate that load one step at a time. Okay. So let me turn it over to Paul. Paul, are there any questions?
Yes, Anand. It's good timing. We have it's 3:45. We have 15 minutes left. So a recent question. I noticed when you ran on the web, there was a period of time when nothing showed before the spinning wheel. Why is that? Is it because of TabJoker?
That's a good question. So it's not because of TabJoker. It's basically because of caching that's initially happening at the back. It was trying to do 2 things. It was trying to uncompress the workbook, move it to the cache that you need on the server before actually displaying it. And that is what caused that lag time.
Okay, another good question. Is this workbook using a live or extract data source?
This is actually using an extract data source. So when you saw the query that we had to actually go in and optimize, you see that it says extract all over the top, right? Construct, it's an extract. But you will see a very similar pattern when you use this against a live connection as well.
Another question, if eliminating a string calc is not an option, what are the best ways to optimize it?
That's a paradox. You'll have to live with the string calculation. Looks like the backend database can't do it. You've got several ways of doing it. If the string calculation is needed, and if it is constant, you can pre-calculate it by actually putting it as a parameter. Now you're using parameters to their advantage. If you cannot pre-calculate, you still have to use the string calculation as is. You'll have to look at other things that you can optimize if you cannot eliminate that completely. But you have ways. If you can move it to the desktop, try to move it to a parameter. If you can't, then we'll have to live with it.
A related question, I think, is displaying the text costlier than displaying numeric, or is it only if you manipulate it?
Displaying does not take a long time. It's only manipulation that are heavy. So if you just have the string and it is prepped for display, Tableau Server and Desktop does a fantastic job of displaying it. It's a visual tool and it does it very well.
I think these two questions are related. If initial load time is the primary issue, is there a way to optimize the compile query? And what ways, if any, can one use to speed up the compiling steps?
Compiling of a query is directly dependent on the complexity of the query. So you will have to reduce the complexity of the query itself. Let us say the query had 50 columns that you have to bring in, and out of that 10 of them are calculations, and on this specific view you don't need all the 50. Let's say you need 15. What you typically do at that time is take only that 15 and move it to a separate connection for this view alone. Or if the query is taking a long time getting all the rows and you're doing some form of an aggregation, you can take that second connection that you just created and pre-aggregate it at that level. Let's say it's at the daily level for the normal query and you want it at a monthly or a yearly level in our case. So you pre-aggregate it to a higher, in this case, date range. So multiple ways of actually reducing that. Reduce the number of columns or aggregate it on the top so that you could get that the number of rows coming back reduced, or the amount of calculation that you need when the query needs to come back reduced too.
So questions are coming in fast now. To benchmark performance recording, wouldn't you have to do exactly the same set of tasks on the Tableau workbook?
That is correct. So that is a classic benchmark. So what I've done is actually shown you how a typical path would go. So in your performance recording, you will have to put the same exact set of steps, copy them into that vizpool.csv that I showed before, and use the same exact view. In this case, I just have one, but you will have all these steps one at a time aligned. Increment this number 1, 2, 3, 4, 5 going forward, and you do the same set of steps while you're doing the performance recording on the web as well.
Okay, next question. Do you offer performance tuning as a service?
Yes, we do, and that was Paul's shameless plug. You're welcome to reach out to us. Okay, give us 30 minutes, give us your workbook, show us what it is. We'll be able to benchmark it on the desktop, on the server, and we'll tell you where it needs to change or how you could make it faster.
Next question, for uncompressing, compiling, query, etc., are there strategies for improving those?
For uncompressing, there is one surefire way of doing it. Speed up the disk on your server. The faster the speed on the server on your disk, the easier the retrieval time is, and faster it will uncompress. That's one way of doing it. Speed up the CPU, yes, definitely. In other words, speed up in hardware, right? As far as the query is concerned, you can optimize the query itself by making sure you follow one of the two strategies I told you, either aggregate up or reduce the number of columns that you would need by taking that connection and duplicating it.
How is the cache handled on the server?
That's a generic question, and it requires a much deeper answer. Welcome to actually send us an email, and we'll definitely take a look at it. Long story short, caching is at different levels on the server. Tableau gives you one big turn on and turn off switch where you could say cache as optimally as possible, cache for 30 minutes, which is typically the average, or cache as long as possible. If you reduce the cache, it will improve scalability with regard to number of users, but there's a trade-off there. The users themselves might experience the workbook at its raw speed and not the speed after which it is cached. Deeper answer, it's on the admin guide on how to look at caching. A lot of blogs out there. Take a look at it.
Is it more efficient to run dashboards without tiled containers on the server? That is, for example, anchoring a worksheet, filter, text box, etc., to a specific pixel on a dashboard.
This is a typical it depends kind of answer. So it depends on the workbook and how many containers you typically have. Your goal is to reduce the containers, and if it is just a couple, unlike the one that you just saw where it was just containers over containers embedded, Tableau does a very good job in pre-processing this on the server and running it.
Is JMX used for the information that populates the performance recording in the targeted workbook?
That's a great question. So this is something like very selective. So it uses JMX at the back to actually go into the server processes and pull them in. And you can configure JMX here in the config inside the data retriever. So you can see all the pieces that it uses under JMX duration, behind the scenes. You'll have to open that up and configure it. Short answer is yes, it does on the server processes. You'll be able to configure it.
I have a workbook with aggregations. What should be the better approach, using live or extracts?
It depends on how frequently your data is changing. If your data is changing so frequently that you cannot do an extract and the extract takes longer than actually connecting live, then you're forced to go live. Typical example, let's say your data changes once in a day, 24 hours. You could take the same data and use extracts for your aggregates and run that way. When you come closer to real time, near real time, as in 15 minutes, 10 minutes, half an hour, that's when you're forced to go live instead of actually taking advantage of extracts.
Does the vizul tab on the server performance monitor correspond to those events in the event log?
It will. So what vizul performance on the server performance monitor aligns to what the JMX counters are. So behind the scenes, it's all JMX counters. So the process, however fast or however slow it runs, is recorded using JMX. That's what's shown in the vizul monitor. That's what we are capturing here.
How do we identify what is the big query and how much time it took?
So query time, you will see on the desktop itself. So let's say you had a long query. Start the performance monitor, open up, let's say, a blank page, like what I showed. So you just take this blank page, just a view, nothing there, start the performance monitor, and then switch over to the view where you are running the query. That will trigger the query to run, and that will actually show you. The only thing you need to do is to make sure that you start off with a fresh workbook and not have something cached.
All right, we have a few minutes and a few more questions. We have a dashboard that is filtered based on the Active Directory information of the user. Does this prevent us from getting any caching benefit for those compiling query events?
Yes and no. So when you're looking at a server-based filter, user filter that is set up, like for example here you see I'm going in as an administrator, right? The query is running as that administrator, and then the query results are coming. So what Tableau does is it's smart enough to see, oh yeah, you've got a user filter, and based on the query that you're going against, it is going to fine-tune, especially in Tableau 9, to say, can I just run this generic query, keep it on my side when I see so many query hits being done, and then reduce it based on the user filter. So there is some performance tuning built in. You will see that in Tableau 9X versions. More recent the versions, the better that performance is going to be.
Another question, we see that level of detail calculations have poor performance that we basically can't use them. What are some general tips on optimizing those level of detail calculations?
Yeah, we've seen that too in our benchmarks. So LOD calculations do take time, basically because it's a query within a query, and that takes time. Multiple ways of handling it. Change the view so that you don't need the level of detail calculation so that you could split it out. But in essence, you will have to tinker with the views so that you don't have to call them. Would be happy to take a look at that and see if we could give alternate paths, but we just have to take a look at the view.
You may have answered this. If you have lots of available memory on the server, can you force more data into the cache?
That's a great question. So there is no way of actually configuring how much data is available on the cache, whether you want to make that bigger or smaller. So there is a data cache process, and you will be able, and it will optimize based on what the size is. So this is as of Tableau 9.2. So every new version that comes out, Tableau has been giving us more control on the server and fine-tuning. Probably in 9.3 that is open, that's being released a couple of weeks from now, you might see that, or you might see that down the line. At this point of time, it's up to the server to optimize that based on how much data it wants to cache.
Okay, we have 1 minute remaining if you want to make some closing remarks on it. I just want to remind everyone that the recording of this session will be available after the webinar provided to you. And please look at our website for future webinar offerings. Thank you.
Thanks, Paul. Hope this was very informative. If you have any questions or updates and you want to take a look at it, please come back to our website. You will have that shortly. Thank you so much, everyone. Have a good afternoon.